Hello students, welcome back to the first session, and we are going to start the first topic in our first unit, Introduction to Refrigeration Systems. So these are the contents of first unit, Introduction to Refrigeration, Unit of Refrigeration, COP, Ideal Cycles, Refrigerants, Desirable Properties, Refrigerants Classification, and refrigerants nomenclature. So today we are going to see Introduction to Refrigeration. So this is the first topic in our first unit. We shall complete in this session itself. So introduction to refrigeration, coming to the definition, it is as simple as this. Refrigeration is the process of removing heat from a substance or space to lower its temperature below that of its surroundings. The removed heat is then rejected to another medium, usually air or water. So this is a very simple definition where the heat is removed from a process or a substance or a space to lower its temperature below than its surroundings. So that is the main purpose of refrigeration. The removed heat is then rejected to another medium, usually air or water. It is obviously surroundings. Then the principle of refrigeration system is that of refrigeration works on the second law of thermodynamics. Already in earlier session we have discussed the three laws of thermodynamics, whereas here the second law is most suitable law, and where we are going to apply this in our entire subject. That states that the heat flow naturally from higher temperature to lower temperature gradient. So this is a simple second law of thermodynamics. A refrigeration system reverses this process by using mechanical work to transfer heat from lower temperature region to higher temperature region. So here refrigeration does this work, and it actually reverses the heat flow from the lower temperature area to higher temperature area, that is surrounding. So from refrigerated space, the temperature is transferred to higher temperature region. So that is it is a reversal process. So equation Q equal to mc into delta T, where the Q is heat energy. It is in terms of joules, m is mass in terms of kg, C is specific heat capacity in terms of joules per kg Kelvin. Delta T is temperature change. It is in terms of Kelvin or degree Celsius. Importance of refrigeration, it requires everywhere. Nowadays, there is no household without a refrigerator. It is actually used in different purposes. Food preservation prevents spoilage by slowing bacterial growth, and air conditioning, it used to maintain the comfortable indoor environments. So it gives us a comfort environment to sleep or to live. So that is the air conditioning purpose. Medical and pharmaceutical applications were essential for vaccine storage, blood banks, and medical laboratories. Industrial applications used in chemical processes, power plants, and metal processing. Cryogenics, ultra low temperature storage for biological samples. Applications of refrigeration in domestic refrigerators and freezers, in air conditioning systems in home, offices, and vehicles, industrial cooling processes, plastic molding, metallurgy, etc. Refrigeration transport, cold storage trucks and containers, preservation of perishable goods such as meat, dairy, fruits, vegetable. So coming to its historical development, it started way back in 17th century, and early cooling methods, ancient Egyptians used evaporative cooling with porous clay pots. So they have used clay pots to bring down the temperature of any substance like water or food to nominal temperature, and it substitutes or it transfers the heat from that food to environment. Romans and Chinese harvested ice for food preservation. So they used ice for food preservation. Milestones in refrigeration technology in 1748, William Cullen is demonstrated artificial cooling. He is the first person who demonstrated artificial cooling. In 1834, Jacob Perkins developed the first vapor compression refrigeration system. So this is the first refrigeration system came into picture in the year 1834, and then in 1876 Carl von Linde developed industrial scale mechanical refrigeration. In 1928 Thomas Midgley Jr. He introduced chlorofluorocarbons CFCs, and then in 1987 the Montreal Protocol initiated the phase out of CFCs. So chlorofluorocarbons, he has just opted out these CFCs, and he demonstrated the cooling processes. So this is a brief historical development took place in refrigeration systems. So basic components of a refrigeration system, there are four basic components, such as the standard refrigeration system consists of four main components. One is compressor. It increases the pressure and temperature of the refrigerant. It increases the pressure and temperature of the refrigerant. And common types are reciprocating, rotary, scroll, centrifugal, and there are other types of compressors. We are going to see in unit 5 unit 4 elaborately about compressors. And condensers releases absorbed heat to the surrounding environment. During compression there will be heat change and there will be temperature change, and it acquires higher temperature, so that is released to environment through condenser. So that is the condenser purpose. And types are air cooled, water cooled, evaporative type. Expansion valve, it reduces the refrigerant pressure before entering the evaporator. Before evaporation process, it reduces the refrigerant pressure. Types capillary tube, thermostatic expansion valve, and there are few other expansion valves are available. And coming to the last one, evaporator. It absorbs the heat from the refrigerated space, converting the liquid refrigerant into vapor. So it converts the liquid refrigerant into vapor. So that is the evaporator purpose, whereas the types are finned tube, shell and tube. So these are the types of evaporators, and we are going to see about all these types: evaporators, expansion valve, condenser and compressor in coming units. Its construction, different types, everything we are going to discuss in future. So basic components of refrigeration system, those four you can see here. These are the compressor. So this is the first component, compressor. So it acquires high temperature and high pressure gas. Gas is nothing but the refrigerant, and once it comes to condenser, it becomes medium temperature and high pressure liquid. So temperature becomes a little lesser, and that pressure is maintained. Pressure is maintained. This expansion valve does this work. It becomes low temperature, low pressure gas or liquid mix. So here it reduces the pressure. So here the temperature is reduced, here the pressure is reduced, and it enters into the evaporator. The evaporator gives medium temperature, low pressure gas. So this is a cyclic process. So this is what is happening in vapor compression system and other refrigeration systems. So this is very basic refrigeration system model. So methods of refrigeration, there are natural refrigeration, ice harvesting, underground cooling, wind towers. These are a few examples of natural refrigeration system. Mechanical refrigeration, it uses compressor to circulate refrigerant through a cycle of compression, condensation, expansion and evaporation. So this is mechanical refrigeration. And then the example is vapor compression refrigeration system, VCRS. Next is absorption refrigeration system. Here it uses heat source instead of compressor. So compressor is replaced with a heat source, and ammonia water absorption system is an example here. And we are going to see absorption refrigeration system as well as VCRS, that is vapor compression refrigeration system, in coming units. Thermoelectric refrigeration, this also we are going to discuss in brief in coming units. It uses electric current to create temperature difference via the Peltier effect. So Peltier effect is used here. And then we have examples: mini coolers, portable refrigerators are examples of thermoelectric refrigeration system. Anyhow, we are going to discuss this thermoelectric refrigeration system also in other refrigeration systems, that is unit 3. Next is magnetic refrigeration. It uses magnetic field to alter the temperature of materials. So this is another unconventional method. This also we are going to discuss in brief in coming units. So methods of refrigeration, a brief comparison. Anyhow, this we are going to elaborately see in coming units. And let me introduce here the refrigeration methods are vapor compression, vapor absorption, air refrigeration, thermoelectric refrigeration, magnetic refrigeration, and cryogenic refrigeration system. The working principle in vapor compression: compression and expansion of refrigerant vapor, whereas in vapor absorption system, absorption and desorption of refrigerant using a heat source, and in air refrigeration, cooling by expansion of compressed air. In thermoelectric, Peltier effect is used, and magnetic refrigeration, magnetocaloric effect, magnetic field manipulation, whereas in cryogenic, extreme cooling using liquid gases, it is helium, nitrogen. These are used. Common refrigerants are given here, and this is designated with R. Nomenclature also we are going to see in this unit. What is R, everything we are going to discuss there. Whereas ammonia water, lithium, bromide water, air is used in air refrigeration. Semiconductor materials are used in thermoelectric refrigeration. This is gadolinium based materials are used in magnetic refrigeration. Liquid helium, liquid nitrogen are used here. So COPs, when you see here, the vapor compression refrigeration system is giving very high COPs, that is 3 to 6, whereas all other gives very low COPs. That is why vapor compression refrigeration system is very popular. It is used in household commercial refrigeration, AC, industrial cooling, and it is potential global warming impact. And here HFCs are being phased out. And if you see here, the absorption chillers, industrial cooling, solar cooling, and it uses natural refrigerants but requires heat source. That is the drawback in vapor absorption system. Here this is air refrigeration, aircraft cooling, gas turbine cycle cooling, and these are eco-friendly, uses air as refrigerant. And thermoelectric refrigeration, portable cooling device, electronics cooling. So here thermoelectric in electronics cooling it is used. No emissions but low efficiency, that is the drawback. Whereas in magnetic refrigeration, advanced refrigeration research, medical cooling, no emissions but still experimental, it is in experimental phase only, not established technology. Magnetic refrigeration. Cryogenic refrigeration, cryogenic space cooling, medical applications, consumes high energy, requires specialized equipment. That is the environmental impact of cryogenic refrigeration. So these are the different methods. I have made a brief comparison here, and whereas in coming units we are going to see elaborately about all these refrigeration systems. So here definition of air conditioning, let me introduce the air conditioning as well here. Air conditioning is the process of controlling the temperature, humidity, air movement and cleanliness of indoor air to provide comfort and suitable conditions for industrial or scientific processes. So that is, indoor environment is it becomes a controlled environment where it controls the temperature, humidity, air movement and cleanliness, and it gives the comfortness to the users. It involves cooling or heating air to maintain desired temperature, and controlling humidity to prevent excessive dryness or moisture, purifying air by removing dust, allergens and pollutants. This is another biggest advantage of air conditioning environment. Circulating fresh air to maintain indoor air quality. So it circulates fresh air, it draws air from environment and it circulates inside, and that is the biggest advantage of air conditioning, air conditioned environment. So coming to refrigeration versus air conditioning, a brief comparison I have made here, and the feature purpose, it is cooling and preservation, that is refrigeration. Comfort cooling is for air conditioning. Temperature very low, below 0 degree Celsius, whereas it is moderate 16 to 30. The applications food storage, medical, industrial, whereas homes, offices and vehicles. Whereas refrigerants are ammonia R134A, R22. Here air conditioning R410A, R32 and R22. So these are the refrigerants. It is very small comparison I have done here. So coming to the textbooks, these are the books. Please refer Kurmi. It is a simple and good book, and also you can refer Aurora Rajput. Apart from that, we have e-resources. These also you can work on it. So these are the topic. This is the topic I intended to complete in this session. In next session, we will see the unit of refrigeration. Unit of refrigeration. It is a simple topic. We will see in next session, students. We stop here. We will meet again in next session. Thank you, students.